Alright guys, welcome to lesson 8.3. We're going to do part 2 of graphing. Today we're going to learn how to graph exponential functions that have some vertical transformations. If you don't remember what those things are, I'll review that with you now. So whenever you have a function, you can do things to it, like put a negative in front of it or add or subtract things from it. And when you do that, that causes an effect on the graph. When you put a negative in front of your function, multiply it by a negative, what that is that creates a reflection across the x-axis. In other words, it gets flipped upside down. Okay? When you add a number outside the parentheses, it shifts your graph up. When you subtract a number outside your parentheses, it shifts the graph down. And it shifts it however far that number is. So if C was a 2, you would shift it up 2 spaces. If it was a 3, you'd shift it up 3, and so on and so forth. So we learned a lot of other transformations, but these are the only 3 we're going to be looking at when we're talking about exponential functions. Okay, so make sure you guys have that written down. Let's go ahead and apply that here. So I'm going to do a little demonstration for you guys on Desmos. So let's begin by putting an exponential function in here. Let's say I'm going to have an exponential function with a y-intercept of 1. I'm going to have it be an increasing function, so I'm going to make it like 1.5 to the power of x, and there it is. So we've got our classic looking little exponential function here. Now, let's go ahead and mess around with it a little bit. So remember what I told you, if you put a negative in front of your function, what does it do? It flips it upside down. So what will that look like? Let's do that. I'm going to put a negative in front of it, and boom. It's the same shape, it just got flipped upside down, right? Okay, let's take that negative off, make it back to where it was. And what did I say would happen if you were to add a number? Well, we said that would shift it up, right? So I'm going to put plus 5. I have the same function as I had before, but now notice it's no longer down here. It got shifted up 5 spaces. Now I'm going to put the original one on there for a second as well and put them on there simultaneously. So here's what it looked. The blue line is what it looked like originally, and after I added 5 to it, that's the red line. Now let's compare those. Notice that on the blue line, my horizontal asymptote was 0, right? It was on the x-axis. But since I shifted it up 5, now where's my horizontal asymptote? Well, now my horizontal asymptote is at 5. So whenever you do a shift up, that shift up is also going to end up being your horizontal asymptote. But it doesn't just affect that, it affects every point on the graph as well. And in particular, we're worried about this point, the y-intercept. So the y-intercept used to be at 1, and that's because the number in the front is a 1, right? But by shifting it up 5 spaces, what happens if you go up 5 spaces from 1? Well, now it's at 6. So as you guys can see, whenever you do a vertical shift, it's going to change your horizontal asymptote, and it's going to change your y-intercept. And how does it change it? Well, basically it adds 5 to them. The horizontal asymptote used to be 0, but now it's 5, because 0 plus 5 is 5. The y-intercept used to be 1, but now it's 6, because you add 5 to it. 1 plus 5 is 6. Okay? And so that's the idea there. You could also do another type of situation where you add 5 and you make the function negative. So now it's been shifted up 5 spaces and flipped upside down. So you could have 2 transformations. You could have a negative causing it to flip upside down, and a plus 5 which causes it to shift up. Okay. One other thing we haven't done yet is what if we did a subtraction? Well, we already know what that does, right? So let's bring it back to normal. So here was the function originally. What happens if I put minus 5? Or we could do minus 10. Let's do minus 10. Now it just shifts the graph all the way down here. So my horizontal asymptote used to be 0, but now what is my horizontal asymptote? Now it's at negative 10. So once again, your horizontal asymptote is just going to be whatever number you have here. What was my y-intercept to begin with? Well, let me clean this up a little bit. Let's get rid of the minus 10 really quick. My y-intercept was 1, right? But as soon as I put minus 10 on there, now what's the y-intercept? It's negative 9. Well, why is that? Because the original y-intercept was reduced by 10, and it was reduced because we're subtracting 10. Okay? So to find your y-intercept, you basically take the value that's in the front, which up until today was our y-intercept, and then you're going to add it to this number over here. So 1 combined with a negative 10 makes negative 9. Okay, so now we've got some idea about how to graph functions with these horizontals. And so here's the main slide we're going to be using for today, so make sure you guys have this and take some good notes. So how are we going to graph exponential functions now that look like this with some transformations added to them? Well, we're going to do the same thing. We're going to find the y-intercept, find the horizontal asymptote, and then sketch the graph, just like we did yesterday. But now things are a little bit different because of these transformations. So how are they different? Yesterday, this was our y-intercept. But today, since it's being shifted up, we're going to add this number to our y-intercept, or our a value, and that will be our y-intercept. So now to find your y-intercept, you do a plus c. Now what else? We also want to find our horizontal asymptote. Now, yesterday, that was 0. But once again, we're adding c to it. So 0 plus c now will be c. So this number, whatever's here, is just going to be your horizontal asymptote. Finally, we have to think about the shape of our graph. Okay. Yesterday, we saw that anytime b was greater than 1, the graph would go up like this. And anytime b was less than 1, it would go down like this. But what happens if we make the number in front a negative? Well, remember, we said that will flip it upside down. So what happens, in other words, if my a value is a negative value? That will flip these upside down. So if a is negative and b is greater than 1, it won't look like this anymore. It'll get flipped upside down, so it looks like this now. And if b is less than 1, it used to look like this, but if I make the a negative, that's going to flip it upside down, so it looks like this. Oops. There you go. Okay? And so make sure you have that chart completed. That'll be helpful for what we're doing today. And just so you guys know, that dotted line represents the horizontal asymptote. So now that we've got that stuff, we're ready to go ahead and do some examples. So let's jump into some. All right, so example 1. So go ahead and write down these instructions. Now you'll only need to write these down once because we're going to use these same instructions for every problem we do. And then after that, go ahead and write down our first problem here. So pause the video and go ahead and start writing that down. And when you unpause it, we'll go ahead and get started with example 1. All right, so let's begin here. For part A, we're being asked to identify and plot the y-intercept. Now that's the number in front. Now a lot of times I use parentheses here, but you don't have to. Instead, they're just putting a dot there, which means the same thing. It just means multiplication. So in this case, my y-intercept is 4. Okay, so let's go ahead and start there. I'm going to plot my y-intercept at 4. Actually, it's not 4, is it? I need to back up a little bit. My y-intercept is 4 minus 1 because it has that shift downwards. So my y-intercept is actually going to be 3. Just put a dot at 3. B. What is my horizontal asymptote? Well, yesterday our horizontal asymptote was 0, but today we're going to be subtracting 1 from that. So now my horizontal asymptote is at negative 1. So now I'm going to draw a horizontal asymptote at negative 1. So there's negative 1. And I'm going to draw a dotted line going through negative 1. So this is different from yesterday. Yesterday my horizontal asymptote was the x-axis. But today it's going to be whatever that c value is on the end there. Okay. Part C, I need to determine what the shape is. Now you can look at the chart or you could just figure it out. It's up to you. I'm just going to figure it out, but you can look at the chart. If you're looking at the chart, you would look at where B is greater than 1 and A is positive. B is greater than 1 and A is positive. Well, what we learned from our lesson yesterday is that when B is greater than 1, it goes up like this. And when A is positive, it stays just like that. It doesn't get flipped upside down. So my graph is going to be flat on the left side. It's going to swing up, hit that y-intercept, and it's going to shoot up on the right side. Okay? And so I've graphed it. That's part C, was to graph it. Now for part D, they're going to ask me to do my end behavior with limit notation. So we're going to do limit as x approaches infinity equals something, and we're going to do limit as x approaches, I'll put negative infinity on this side and positive infinity on this side. There we go. So what's happening on the left side of my graph? Well, it's getting flat, but not against 0 this time. What's it getting flat against? It's getting flat against -1. And what's happening on the right side of my graph? We've got an infinity here. So let's go ahead and put infinity there. So that's example number 1, parts A, B, C, D, and D. Let's go ahead and take a look at the next one. I'm going to be doing the odd problems on this worksheet, so I'm going to do number 3 next. So see if you guys can beat me to the punchline here. A, what is the y-intercept? To find the y-intercept, you take your A value, and you're going to combine that with your C value. -2 plus -2 is -4. So my y-intercept is going to be -4. And why is that? Because this is usually our y-intercept, but it got shifted down 2 more spaces. So it was at -2, and then it got shifted down 2 more spaces. So now we're at -4. Identify and sketch your horizontal asymptote. The horizontal asymptote is the number that's over here, the C value. So we're going to have a horizontal asymptote at y equals -2. So I'll just label that as B. Next, we want to sketch the graph. Well, the graph is, we've got a -A and a B value that is less than 1. So look at your chart. Find where B is less than 1. Find where A is negative. Now, instead of looking at the chart, I'm just going to figure it out. I know that when B is less than 1, it usually looks like this. But it's getting flipped upside down because we have a negative. So it's not going to look like that, actually. It's going to look more like this. And so my graph is going to be going downward on the left side. It's going to swing up, hit that, and then it's going to get flat on the right. So it's going like that. Now we're ready for our end behavior. What's going on the left side of my graph? And what's going on the right side of my graph? On the left side, it's going down into negative infinity. Since it's going down, where we say negative infinity. What's happening on the right side of my graph? On the right side, it's getting flat up against this horizontal asymptote of -2. Let's go ahead and take a look at another one. All right. So for part A, we want to find our y-intercept, right? So to do that, you take your A value and add to it your C value, but you'll notice we don't have a C value. What's it going to be when it's missing? Well, we talked about how when the A is missing, it's 1, but when the C is missing, it's going to be 0 because it's an additive number instead of a multiplicative number. So my y-intercept is 1/2 plus 0, which is 1/2 still. All right? So that's my y-intercept. Let's go ahead and plot that. 1/2. Well, if this is 1, then a half would be like maybe between 0 and 1. All right, part B. Identify and sketch your horizontal asymptote. The horizontal asymptote is whatever number is here. Now there wasn't a number there, but we said that if it's not there, it must be 0, which means that we're back to yesterday's types of problems. We're right on the x-axis. So that's part B. Part C, let's take a look at the shape. Well, I've got a B value that's less than 1, so it's going in a downward direction like that, but the A, it's still positive, so it doesn't get flipped upside down, so it's going to look like this. So my graph is going to be up on the left, it's going to hit that y-intercept and get flat on the right. And there we have it. Now we got to do our end behavior here, so let's do part D. We've got our graph, C. The limit as x approaches negative infinity will tell me what's happening on the left side of my graph. And the limit as x approaches positive infinity will tell me what's happening on the right side of my graph. So on the left side, it's going up, so that would be positive infinity. On the right side, it's getting closer to the horizontal asymptote, which is 0. All right, number 7. Let's do another example. So for this problem, you'll notice that we're missing our a value. We have our b, it's 4, being raised to the x power. The a value is missing in the front, so that's a 1. So when the a is missing, it's 1. When c is missing, it's 0. So there's our problem. So for part A, to find our y-intercept, we take the a value and we add it to the c value, which gives me a total of 2. So we're ready to put our y-intercept on there, 2. Next, we want to identify our horizontal asymptote, which is the number that's being added at the end. That's a positive 1. So we're going to have a horizontal asymptote at 1. All right. That's part B. Part C, we're ready to graph it using the chart. So in this case, my b value is greater than 1 and my a is positive. And when that happens, your graph is flat on the right and goes up on the left. And there's our part C. And then finally, part D, we want to do our end behavior limit notation. What's happening on the left side and what's happening on the right side of our graph. Well, on the left side, it's getting flat against the horizontal asymptote, which is 1. And on the right, it's going up forever, which is positive infinity. We'll do one more example together before we call it quits. Okay, this one has fractions and negatives, so it can get a little bit confusing. So I thought I would include one of these. So let's begin. Part A, let's find our y-intercept. We get that by taking our a value and adding to it our c value. All right, so what is negative 1/4 plus 2? Well, I say go ahead and just change it to a decimal and use your calculator. So using your calculator, if you just do 1 divided by 4, you're going to get 0.25. And so we have negative 0.25. And then if I add that using my calculator, once again, I get 1.75. If you could do that mentally, that's awesome, but feel free to use your calculator. But there's my y-intercept. It's 1.75. So we're going to go ahead and plot that. If this is 1 and this is 2, 1.75 would be about 3/4 of the way through there like that. Part B, let's go ahead and find our horizontal asymptote. Horizontal asymptote is this number right here, which is 2. So I'm going to go ahead and draw my dotted line at 2. So the horizontal asymptote is really close to the y-intercept this time. All right, that's part B. Now we're ready for part C. On part C, I'm noticing that my b value is less than 1. So that means that typically my graph would be up on the left and flat on the right, like that. But notice that my a value is negative, and so what's going to happen is that's going to get flipped upside down. I thought it would let me flip it upside down, but I don't think it'll let me. Oh well. If I flipped it upside down, then it would look like this, right? So that's the picture we're going to get. So it's going to be going down on the left side. It's going to swing up and hit that y-intercept, and then it's going to get flat on the right side. And there it is. And that's part C. And then finally, we're ready for part D. What's happening on the left side? And what's happening on the right side? On the left side of my graph, it's going down, so we're going to put negative infinity. And on the right side, it's getting flat up against that asymptote, which was at 2. There we have it. All right. So I've got some examples here. You guys don't have to do all of these. I feel like we've kind of really beat it to death. Why don't we have you guys go ahead and do numbers 6, 8, and 10. And pause the video. When you unpause it, we'll have the solutions available for you for 6, 8, and 10. Cover up these guys because we're not worrying about those anymore. Here we go. All right, guys, so here's your solutions. Your graph on number 6 should have looked like that. Here's the work down here. And then 10. Here's the stuff for 10. And here's the stuff for 8. So I'll let you guys go ahead and check your work there, and we'll go ahead and follow up with that in class, and we'll see you guys then. Have a good night. Bye.